Okay, so now let's look at another theorem. It's called the Integral Zero Theorem, and that is a very special theorem. It talks about the relationship between the factors of the polynomial, of a polynomial function, and its constant term. Okay, and basically what it means is that you have this constant term. So suppose you have this polynomial here. This 12 is called the constant term. It doesn't have a variable. Okay, and it says basically that if this polynomial has all the leading coefficients of any of the terms are all integers, so 7 is an integer, 1 is an integer, so it cannot be a fraction or decimal or anything like that. It has to be integer values for coefficients. If this polynomial has any factor of the form x minus a right here, then this a has to be coming from the factors of 12. That's what it means. So let's look at this example that you know already. Can we put that into a factor form? And it is a factorable trinomial. And when you factor that, you get x plus 3 and x plus 4. So what are the factors? Both of these guys are the factors. That's the factor, that's a factor. Both are factors. In fact, if you do a long division, one is the quotient, the other one could be a divisor, and vice versa. But we know these two are the factors because we don't have any remainder. So no remainder, right? No remainder. That means these are the factors. Okay? No remainder. All right. Now look at what 3 and 4, what are they in reference to 12, in relation to 12? Well, 3 and 4, they are factors of 12. Okay? So make a note that 3 and 4 are factors of 12. Now we already knew that, so that's okay. We already knew that, so we just showed. But what if you didn't know that? Well, you have to write up all factors. So what are all factors? So what are all factors of 12? Let's go ahead and do all factors of 12. All factors. And again, we are looking at 12 because 12 is the constant term of the polynomial. All right. What are the all factors? Now, factors positive and negative. Okay, all of them. And start with the 1. So plus or minus 1, right? Plus or minus 2, plus or minus 3, plus or minus 4, 6, and then the last piece, plus or minus 12. Now, if you didn't know that 3 and 4 are the factors, then what you had to do, you had to actually go through each of these possible values of a, use the remainder theorem, and make sure that the remainder becomes 0. And if it is 0, therefore you can say that's a factor. Okay, so that's what you have to do. So let's go ahead and do another example, and then we'll see. Okay, here's an example. We want to know if f of x, this polynomial function, has any factors of the form x minus a. Okay, and if it does, then we can write it out, and that's okay. So what we need to do is that we look at the constant term. So that's 3. We need to come up with all factors of the 3, and that is plus or minus 1, plus or minus 3. Those are the only 4 possible factors. If there are any integral factors, that would be it. So let's go through. Now we have to use the remainder theorem. So if they are the factors, we're going to go systematically one at a time. So first we need to know if f of 1, so I'm going to use all of them. So we have to do f of 1, f of negative 1, f of 3, and f of negative 3. We want to check if any of these guys will, after doing the math, they will give you 0. Because if it is, that means the remainder is 0. That means there are factors. So we're going to go through and do the math. So here it is. So grab the 1, plug it into the x, into the original function, and do the math. So here it is. We're going to start with the 1, replacing x with 1, and do the operation. Okay, for each one of these ones, go ahead and do that, and let's see what you will get. Okay, so I started with f of 1, plug it in there, I got -4, that's not 0, so we can say that therefore we know that x minus 1 is not a factor. All right, very good. So this is not 0. The remainder is not 0. And if it's not 0, x minus 1 is not a factor. Okay, so now let's go ahead and check the other ones. So now we plug in the next factor, -1. Okay, so f of -1, is that equal to 0? And you notice that when you do the math, yes, it is. Therefore, what you can say is that in this case, therefore x plus 1, remember that -1, you plug it into for the divisor, makes it a 0. That's what that is. So therefore x plus 1 is a factor of the polynomial. So yes, we found one factor. Great. Let's check the other ones. 3 and -3. Okay, so the last two plus 3, I plug it in there, and you notice that yes, it will be 0. Okay, and that means what you can say is that if that's the case, therefore x minus 3 is a factor. Excellent. And I went ahead and did the f minus 3 as well, but it turns out that it's not going to give you 0, it gives you another number. So therefore that is not a factor. So the two factors that we got, two integral factors, two factors that we got that looks like x minus a, is one is x minus 3, and the other one that we got was x plus 1. Okay, now that means that if you go ahead and do the long division, what will happen is that there's another factor you're going to get, and the other factor will end up being 2x minus 1. Okay, you can use either one of these two and factor using a long division. You're going to get the third one in there, 2x minus 1, but 2x minus 1 doesn't look like the x minus a that originally the integral zero theorem talks about. Okay, it has to look like x minus a. All right, so in this case turns out that it's 2x minus 1, and then all three are factors, but two of them looks like x minus a in the form of x minus a. All right, couple other things. Remember, when you have your function set equal to 0, so it doesn't matter what the number you have, if f of x equals to 0, that means you're looking at your x intercepts for values of x. When you solve that, you're getting x intercepts, and these possible integers, or for this value, these values, the integral zero theorem, these values of plus minus 1, so x equals to -1 and x equals to -3, these are, okay, these are the ones that we just got, plus or minus, those are the integers that we got and plugged in there. These are the factors of the constant term. These are the x-intercepts of the polynomial function. In this case, we have a cubic function. Now, there is another x-intercept. It's just that we can't solve it using integral zero theorem. We have to use, this is another one right here. So this x value will end up being x equals to 1/2. That is also an x-intercept. It's just that it's not an integer value. Okay, so that is also an x-intercept right here. That is the x-intercept. But it's just that you can't get it through the integral zero theorem. Okay, so very important. We're going to talk about that in the next section.